Hello, my dear students. Our lesson for today is how to graph proportional relationship. Let's start. What we will learn today. First, to determine whether the two quantities are proportional by graphing them on a coordinate plane. Our new vocabulary: coordinate plane, order pair, x coordinate, y coordinate, y-axis, origin, and x-axis. Let's try this example. The slowest mammal of Earth is tree sloth. It moves at a speed 6 feet per minute. Determine whether the number of feet the number of feet the sloth move proportional to the number of minutes. It moves by graphing on the coordinate plane. Explain your reasoning. First of all, we have to make a table to find the number of feet moving from 0 minutes till, for example, 4 minutes. When we make this table, as we see in this example, it moves 6 feet per minute. So when it's 0, the time is 0, no distance. So 1 minute, which is this rate, 1 minute, it moves 6. So the 2 minutes will be 12, the 3 minutes will be 18, and the 4 minutes will be 24. Graph the order pairs with the time distance on the coordinate plane, then connect the order pairs. Here we have x-axis and y-axis. And now let's graph together to be more clear. Here we plot the dots according to the numbers which are in the table. When it's 0, there was 0 time and 0 distance. So this is the first dot. The second is when I moved 1, it was 6. So the 6 here before 8. And when it was 2 minutes, the distance was 12 feet. So when the 2, it reached 12. And 3 is 18. 3 is 18, and the 18 here before 20. I can plot the dots here before 20. And the 4, it was 24. Now I have finished plotting the dots. The second step is to draw the line. And when we draw the line here, we can find that the line started from the 0 and it's a straight line moving through these dots. So the relation here is linear, passing through the origin, which is the 0 point. So the line passes through the origin and it's a straight line. So the number of feet traveled is proportional to the number of time. From this graph, I can say that the relation between the time and the distance is proportional. Why they are proportional? Because it formed a straight line passing through the origin. So the proportional relationship from the graph is linear relationship and passing through the origin. If it's a linear not passing through the origin, it's not proportional. Or if it's passing through the origin, but it's not forming a line, it's curvy, it's also not proportional. So the relation can be said that the relation is proportional when it's forming a line passing through the origin. Okay, let's move to the next example. Here, a hot air balloon is at 140 feet distance, 20 feet per minute. Determine whether the height of the hot air balloon is proportional to the number of minutes and explain your reasoning. Here, the relation here is forming a line, but it's not passing through the origin. It started from 140 and coming down and down and down. So here the relation is not proportional. Why? Because there is no passing through the origin, which is the 0. If I have here a relation between number of video games and its cost, 1 costs 3, 2 costs 5, and 3 costs 7, 4 costs 9. Write the quantities in order pairs. And when we say that we have to write it in order pairs, we write it like x-axis and y-axis. So 1 in 3, 2 is 5, 3 is 7, and 4 is 9. Then graph the order pairs. Let's start graphing the order pairs. First, when it was 1, the cost was 3. So I will plot the dot here. 2 is 5. 3 is 7. 4 is 9. Now we are plotting the dots. This is the first step. Let's try the second step, and the second step is to draw the dots. Connect the dots together. Let's connect the dots together. When we are connecting these dots together, I will form this line. But this line, it's not passing through the origin. Let's try to extend the line. If it's passed through the origin, so I can say that relationship is proportional. Now, it didn't passing through the origin. So when we graph the order pairs, the line doesn't pass through the origin. So the cost of video games is not proportional. They are proportional if I extended this line and it passed through the origin, but it didn't pass through the origin, so the relationship is not proportional. When we have the table, number of seconds and number of time, and these are 0 and 0, 5 and 2, 10 and 5, and 5 and 10. Without graphing, can we see that the order pairs, we have 0 and 0. So I think in the first, I can say that the first condition is done, that I'm passing through the origin. But I have to graph to be sure that this relationship is proportional or not by forming a straight line. When we graph, it doesn't form a straight line, but it passed through 0. But now I can say it's not proportional. Why? Because the graph is not a straight line. I passed through the 0, but I'm not a straight line. So the relation here between the number of seconds and the number of rotations are not proportional. Here we have two proportional relationships, that the number of inches thrown in the cost. So the first is softball and the second is fun center. What are the proportional here? First of all, the softball is not proportional. Why? It forms a straight line, but it's not passing through the origin. But here, the fun center, I can say that the relation between the number and the cost is proportional because it's forming a straight line, so it's a linear relation, and passing through the origin. Let's move to the next. Here, which person represents the proportional relationship between time and number of levels passed and explained? Jen Morgan. I can say that the relation between the time and levels for Morgan is proportional because it's forming a line and passing through the origin. But here, Jen is not proportional. The relation with Jen is not proportional. Why? Because it doesn't form a straight line. Here, the straight line can be a broken line and it passes through the origin, but it doesn't form a straight line. So it's not proportional. So Morgan's graph is straight line through the origin. Thank you for listening and have a nice day.